Hello viewers, welcome to the lecture series of SSC Quantitative Aptitude, and this is your tutor Keshav Agarwal, and this is lecture on LCM and HCF. In this lecture, we are going to solve 25 questions on LCM and HCF. Let us start with the very first question. If three numbers 2a, 5a and 7a are given, then what will be their LCM? So required LCM is given by a times of 2 times of 5 times of 7, that is equal to 70a. So the correct option here is option A. Question number 2. Find the LCM of 2 cube into 3 into 5 square into 7, 2 to the power 4 into 3 square into 5 into 7 square into 11, and 2 into 3 to the power 3 into 5 to the power 4. So we have three numbers and their prime factorization is given. We have to find their LCM. So given prime factors are in front of you, and the required LCM is product of prime factors having highest power. Choose the highest power of each number from each of the numbers. So we have 2 here. This is 3 power, this is 4 power, and this is 1. So we will have 2 to the power 4. 3 power is 1 here. This is 2 and this is 3. So we will choose the highest power, which is 3 to the power 3. And this 5 power is 2. Here it is 1 and it is 4. So we will choose 5 to the power 4. 7 power is 1 here. Here it is 2. And this is power 0 for 7. So we will choose 7 square. 11 power is 0. Here it is 1. Here it is 0. I will choose 11 to the power 1. So this is the required LCM. So the correct option here is option number C. Question number 3. The HCF and LCM of two numbers are 21 and 84 respectively. So 21 is the HCF and 84 is the LCM. So if the ratio of two numbers is 1:4, then the larger of the two number is. Let the smaller number be x and the larger number be 4x. So we have reduced this information from this ratio that is given to us. Then the product of their number is equal to product of LCM and HCF. That means x into 4x is going to be 21 into 84 because LCM and HCF are known. So we can write it as 4x square equal to 21 into 84. And you see, when you simplify this, you will have x equal to 21. Then required largest number is 21 into 4 because when you have x, so you just put the x in this 4x, you will get 84. The option correct here is option number C. Question number 4. Find the HCF of 132, 204 and 228. So at the first step, we take two numbers 132 and 204, and the HCF of 122 and 204 is 12. Again, take HCF of 12 and 228, so it is going to be 12. Hence, HCF of 132, 204 and 228 is going to be 12. So the option correct here is option number A. GCD or HCF of A plus B minus C to the power 6 and A plus B minus C to the power 4 is. So GCD is A plus B minus C to the power 4 because A plus B minus C to the power 4 is the greatest common in both the powers which are given to us. So the correct option here is option number D. Question number 6. Find the LCM of 1 upon 3, 2 upon 9, 5 upon 6 and 4 upon 27. Solution. We know that LCM of fractions is given by LCM of numerators divided by LCM of HCF of denominators. So the LCM of numerators is going to be LCM of 1, 2, 4, 5 and 4. And HCF of denominator will be HCF of 3, 9, 6 and 27. So LCM will be 20 and HCF will be 3. So the answer is 20 upon 3. So the correct option here is option C. Question number 7. The traffic light at 3 different road crossing changes after every 48 second, 72 second and 108 second respectively. If they all change simultaneously at 8:20 hour, then at what time will they change again simultaneously? Solution. Interval of change is equal to LCM of 80, 48, 72 and 108. So it is equal to 432 seconds. That means 7 minutes 12 seconds. Thus, the light will change after 7 minutes 12 seconds. So time of next change will be 8:27 and 12 hours. That means option correct here is option A. Question number 8. Find the LCM of x to the power 4 minus 1 and x square minus 1. So x to the power 4 minus 1 is equal to x square minus 1 into x square plus 1. This implies that x square minus 1. So LCM of given polynomial is x to the power 4 minus 1. Hence, option D is correct. Question number 9. Find the HCF of 4 by 5 and 7 by 15. Solution. We know that the HCF of fractions is equal to HCF of numerator and LCM of denominator. Therefore, the HCF of numerator will be HCF of 4 and 7 divided by LCM of 5 and 15. So it will be 1 upon 15. So the option correct here is option C. Question number 10. The LCM of two numbers is 2376, while their HCF is 33. If one of the number is 297, then the other number is. Given LCM of two numbers is 2376 and HCF of two numbers is 33 and one of the number is 297. So we know that HCF of two numbers into LCM of two numbers is equal to first number into second number. And HCF is known, LCM is also known, the first number is also known. We don't know the second number. So we have 4 quantities here, out of which one is unknown and the other 3 are known. So we can easily find the fourth quantity. So therefore the second number will be 33 times of 2376 upon 297, which is equal to 264. So the option correct here is option B. Question number 11. The ratio of two numbers is 3:4 and their HCF is 4. What will be their LCM? So according to the question, first number equal to 3x, second number equal to 4x, where x is equal to HCF. But given is x equal to 4. We know that LCM is equal to product of two numbers upon HCF. So it will be 3x into 4x upon x. So LCM is going to be 12x, that is 12 into 4, which is 48. So the correct option here will be option number D. Question number 12. The HCF of three numbers is 23. So we have three numbers and their HCF is known. If they are in ratio 1:2:3, then find the numbers. So let us suppose three numbers be x, 2x and 3x, where x is the HCF. So it is already given that 23 is the HCF. That means x equal to 23. Therefore, the numbers are 23, 46 and 69. So the correct option here is option B. Question number 13. The LCM of two numbers is 495 and their HCF is 5. If sum of the numbers is 100, then find the difference of the numbers. So solution, given LCM equal to 495 and HCF equal to 5. So the first number is equal to x and the second number is equal to y. So xy is going to be 495 into 5, as the product of two numbers is equal to LCM into HCF. So this implies that xy is equal to 2475. And we know that x minus y whole square equal to x plus y whole square minus 4xy. So we can substitute the values. We will have 100 square minus 4 times of 2475. That is equal to 100. Therefore, x minus y is going to be 10. So the option correct here is option A. Question number 14. Let x be the least number which when divided by 5, 6, 7, 8 leaves remainder 3. So x is the least number which is when divided by 5, 6, 7 and 8 we get remainder 3. But each case, but when it is divided by 9 it leaves no remainder. So the sum of digits of x is, so LCM of 5, 6, 7 and 8 is equal to 840. Then the smaller number x is equal to 840k plus 3 divided by 9. So 840k into 2 plus 3. Here we have substituted k equal to 2. So we get 1683. Therefore required sum is equal to 18. So the option correct here is option D. Question number 15. The sum of two numbers is 1056 and their HCF is 66. So find number of such pairs. Let number be 66A and 66B, where A and B are co-prime. So according to the question, 66A plus 66B is 1056. So taking 66 common and sending it to the right hand side, you will get A plus B equal to 16. So possible values of A and B are A equal to 1 and B equal to 15. So this is B here. And A equal to 3, B equal to 13, A equal to 5, B equal to 11, A equal to 7, 6, B equal to 9. So the numbers are 66 into 1, 66 into 15, 66 into 3, 66 into 13, 66 into 5, 66 into 11, 66 into 7 and 66 into 9. So therefore the possible number of pairs are 4. So the option correct here is option C. Question number 16. If A, B and C start at the same time in the same direction to run around a circular stadium, A completes a round in 252 seconds, B completes the round in 308 seconds, and C completes the round in 198 seconds. So all starting at the same point, after what time they will meet again at the starting point. So solution, required time equal to LCM of 152 second, 308 second and 198 second. So which is equal to 2 times of 3 times into 11 into 14 seconds, which is equal to 2772 seconds. And if I have to write it in minutes, it is 46 minutes 12 seconds. So the option correct here is option C. Question number 17. Find the greatest number of 3 digits which when divided by 6, 9, 12 leaves remainder 3 in each case. So the solution, the greatest 3-digit number is 999, correct? And LCM of 6, 9, 12 is equal to 36. Now 999 divided by 36 is equal to 27 of 27 upon 36. Therefore, the remainder is 27. The required number is 999 minus 27 plus 3, which is equal to 975. Hence, the option correct here is option A. Question number 18. Find the greatest number that divides 130, 305, 245, leaving remainder 6, 9, and 17 respectively. So in this question, it is given that x is equal to 130, y is equal to 305, and z equal to 245. And we take a equal to 6, b equal to 9, and c equal to 17. So according to the formula, required number is equal to HCF of 130 minus 6, 305 minus 9, 245 minus 17. So the HCF of 124, 296, 228 is 4. So the option correct here is option A. Question number 19. In a store, there are 345 liter mustard oil, 120 liters sunflower oil, and 225 liters soybean oil. So what will be the capacity of the largest container to measure about 3 types of oil? So required capacity is equal to HCF of 345 liter, 120 liter and 225 liter. So you have to just find the HCF here. The required capacity of container to measure the oil will be 15 liters. So the option correct here is option D. Question number 20. The greatest 4-digit number exactly divisible by 10, 15, 20 is. Solution. The number exactly divisible by 10, 15, 20 is equal to LCM of 10, 15 and 20, which is equal to 60. Now the greatest 4-digit number, that is 9999. So required number is going to be 9999 minus 39, which is equal to 9960. So the option correct here is option B. Question number 21. A, B and C go walking around a circle 1 kilometer in circumference at the rate of 10 minute, 10 meter per minute, 20 meter per minute, and 40 meter per minute, respectively. If they all start together and walk in the same direction, when they will they be together at the same place? So time taken by ABC to make round is 1000 upon 10 minutes, 1000 upon 20 minutes, 1000 upon 40 minutes. So it is going to be time taken by A will be 100 minutes, time taken by B will be 50 minutes, and time taken by C will be 25 minutes. So required time will be LCM of 100 minutes, 50 minutes, and 25 minutes. That means 5 times of 5 times of 2 times of 2, which is 100 minutes. Hence, they will together be at starting point after 100 minutes. So the option correct here is option B. Question number 22. The largest number which divides 77, 147 and 252 to leave the same remainder in each case. Solution. Required number is equal to HCF of 147 minus 77, 252 minus 147 and 252 minus 77. So HCF of 70, 105 and 175 is equal to 35. That means 70 minus 2 times of 5 times of 7, and 70 is equal to 2 times of 5 times of 7, and 105 is equal to 5 times of 3 times of 7, and 175 is equal to 5 times of 5 times of 7. So the HCF is going to be 5 into 7, which is equal to 35. So the option correct here is option D. Question number 23. The greatest number which can divide 1354, 1866 and 2762, leaving the same remainder 10 in each case is. Solution. So required number is equal to HCF of 1354 minus 10, 1866 minus 10 and 2762 minus 10. So the HCF of 1344, 1856, 2752 is going to be, so the prime factorization for 1344 is 2 to the power 6 into 3 into 7. For 1856 it will be 2 to the power 6 into 29, and 2752 it is going to be 2 to the power 6 into 43. So these are the prime factorization, and check which is the highest power common powers that we can choose. It is 2 to the power 6. So HCF is going to be 2 to the power 6, that is 64. So the option correct here is option A. Question number 24. Two 3-digit number have their HCF 29 and their LCM 4147. So the sum of numbers is, let the number be 29A and 29B, where A and B are co-primes. Then 29A times of 29B is equal to 29 into 4147. So AB is equal to 29 times of 14147 divided by 29 into 29, that is 143. So co-primes with product 143 and 11 and 13, co-primes with product 143 are 11 and 13. Therefore, the numbers are 29 into 11, 29 into 13, that is 319 and 377. So their sum is going to be 696. So the option correct here is option C. Let us now see our last question, that is question number 25. The greatest number of 5 digits which is divisible by 15, 36 and 21. Solution. Required number is divisible by LCM of 15, 36 and 21, that is it is divisible by 3 times of 5 times of 12 times of 7, that is equal to 1260. 1260. So the greatest 5 digit number is 99999, that means 5 times 9, and on dividing 5 times 9, that means 99999 by 1260, the remainder is going to be 4591. 459. So if I subtract the number by 459, I'll have 99540. So the option correct here is option B, that is 99540. So that would be all for this lecture. Thank you very much.